Hello friends, so today we can discuss the first 4 problems from the latest At Coder Beginner Contest 181. So let's start. The first problem is heavy rotations. So it's a very simple problem. Takahashi is wearing a white color now and he wears black on the day after he wears white, and then he wears black, so it's just alternating days. So what color he will wear after the n day? If today is white, which means that today, just you can assume that today day is 0, and then the next day is 1, the next day is 0, like so on. So it's just alternating days. So you have to find out that if the number is even, then it is white, and if the number is odd, then it is black. So you just have to find out that if it is even or odd. So that's a very simple logic. Okay, let's move on to the second question. Second question statement name is trapezoid sum, in which we have a blackboard with nothing written on it. Takahashi will do n operations to write integers on it. In the ith operation, he will write each integer from ai through bi once. So if you are given a and b, then from ai till bi you will write down all the numbers once for a total of bi minus ai plus 1 integers. As you can see, find the sum of all the integers written on the blackboard after the n operation. So you are given like a1 till b, so a1 b1, a2 b2, and so on, and a and bn. So you have to write down all the numbers. As you can see, 1 till 3, 3 to 5. So 1 till 3 means 1 2 3 3 4 5, and you just have to do the summation of all of these numbers. So if you know how to do or find out the summation of all the n numbers, then this problem sounds very simple. Okay, I'll use a drawing board. Just wait 1 second. Then this problem just seems very simple, in which you just have to find out the summation of the first n numbers, and because you know that you have to find a summation for 3 to 5, so what you can easily do in this problem is, if you have to find out the summation for 1 till 5, okay, sorry, yeah, 1 2 3 4 5, so you have to include both 3 and 5. So do a summation till 5, so which is n into n plus 1 divided by 2, and so this is like b, which is given to you, so b into b plus 1 divided by 2. And now you are given also a, but you have to do a summation not till a, sorry, if you have to subtract, you have to subtract not till a but a minus 1. If you find out the summation from 1 till a minus 1, then if you subtract out the summation from a till this minus this, then you'll get the answer. So this is a minus 1, so just put down in this formula, which is a minus 1 into a divided by 2, and you just do a summation of this value minus this value over all the actually the constraints, or actually all the queries you are given, and that's the whole logic for this problem. I'll shoot on to the code part now. So this is y, which is a and b. As you can see, x or y is just y into y plus 1 divided by 2, and this is x into x minus 1 divided by 2. As I've told you, that's the whole logic, and you just print out the summation over all these values. So this is addition and this is subtraction, and just find out the total. So next question is collinearity, in which you have n points on a 2-dimensional infinite coordinate plane. As you can see, the ith point is given xi yi. There is a triplet of distant points lying on the same line among the n points. So you are given n points in the coordinate plane, and you have to find out whether the 3 points lie on the same line. Okay, so now how you can check that out? This problem is like, because the constraints are very small, as you can see, its n is just 100, so you can do a O of n cube operation, and also you have to find out 3 points, so you just have to iterate over every point, because you can do an O of n cube for every 3 points. Just check that whether they lie in the same point or line, or same line or not. How you can check that whether 3 points lie in the same line? Let's assume that I have these 3 points. Okay, so let's assume this is x1 y1, x2 y2, x3 y3, and if 3 points lie in the same line, then, or if like this point and this point is there, now this is forming a line, so the slope of this line is constant, which means that if you just find out the slope using these 2 points or these 2 points, then the slope must be same. So how do you find the slope with these 2 points? It's just like y2 minus y1 divided by x2 minus x1, and if you find the slope using this point and this point, then this is y3 minus y1 divided by x3 minus x1. And then if you just divide this sum, then actually it can do or give some values which is in point, which means that you should find out this value minus that, divide this value, and also do the same, then it might get into points. So what it's simpler is cross multiply this. So what does this mean is, find out y2 minus y1 into x3 minus x1, and if this turn out to be equal to y3 minus y1 into x2 minus x1, then it's fine. So that's what we're gonna do in this problem. I'll show you on to the code part now. So take a bit of all the endpoints in this vector, which is of pair of vectors, then iterate over all the points in the triplet. So you have to do an n of O of n cube solution. So I is from 0 till n, j is from I plus 1 till n, k is from j plus 1 till n, and then find out the coordinates. So x1, which I've told you, so this is 1, so I have like marked this one is x1, this one is y1, this collectively thing is y1, I've told you, and this is y2, and this is x2. So that's what I've done. X1 is just a of j, j is the second point, so second point minus first point, this is the x coordinate, and same for the y coordinate, or the second minus first point. So this is second point minus first point will give you one slope, and same, this is the third point, which is k minus the first point, so third point minus the first point, y and x both. So that's what I find. And if x1 into y2 is equal to x2 into y1, then the answer is yes. If you just find out any one answer, then the answer is yes, and you just return out at this point. If you just don't find out any triplet, then the answer is no after finding out or checking out all the triplets. And that's the logic for the third problem. Let's move on to the last problem now, in which the problem is Hachi, in which you are given a digit sequence S consisting of the digits from 1 till 9, and Takahashi the B loves multiples of 8. Now he's trying out to make a multiple of 8 by permuting the digits of the sequence of S. So you're given a long sequence of S, as you can see. S is a very large number up to 2 into 10 to the power 5, and then you have to find out whether after permuting these digits can you form a number which is a multiple of 8, and that's the question. Now you can easily Google it out, or if you know, it's very good. What is the condition for a number to be a multiple of 8? The condition is the last 3 digits, okay, or actually consider last digits, collectively last 3 digits will, if the number is greater than 3, okay, if the number is 1, the size of the number is 1, then it is always 8, okay, because the number cannot be 0, it is always greater than 1. So if it is size 1, then it should be always 8, because no other number is multiple of 8 if it's size 1. If it is of size 2, then I have two options. So let's assume the number is AB. AB means that this is the first number, this is the second number, which means that it can be 64 or 32. So you have to check that the number which is given to you, maybe the number given to you is 23, then you can permute it out, which is 32. So you have either two choices. You can either take this number which is AB or BA. You can check that whether AB is a number which is a multiple of 8 or BA is multiple of 8 when the size of this number is 2. If the size is greater than 2, which is 3 or more, then the condition hold is the last 3 digits should be a multiple of 8, then the whole number can be a multiple of 8. So you just have to check out that the last 3 numbers can be a multiple of 8. How you can check that out? Maybe if you just know that the last 3 digits, so the last 3 digits only, the first multiple of 8, which is of size 3, is 104, and then you can keep iterating out, because this is the 3-digit number. You just have to like check at most like 20-30 like values till 1000, which is the 4-digit number. So between this value and this value, you have to just find out like what 3-digit numbers are there which is a multiple of 8, and if this number exists. So because let's assume that 104 is a multiple of 8, I have some numbers in S. S means the value or the sequence of numbers I'm giving, which is, let's assume 1 2 3 4 4 4. Okay, so now what I'll do, I'll find out the count of every number and I'll store it in some map. Okay, and then what I will do, for all the numbers of size 3, I will also find out their frequency, which is like 1 occurs one time, 0 occurs one time, 4 occurs one time, and I will check that whether this number can be built using the numbers given in S, because if it can be built, I can somehow permute only this 104 in the end, and then the numbers before it can be something else, I don't care, just the last number should be a multiple of 8. So I have to ensure that if this, I know that 104 is a multiple of 8, I can find out all the multiples of 8 of size 3, because there are only some handful of numbers of size 3 which are multiple of 8. I can just iterate out and find out all the values, and if I can find out that if this value is a multiple of 8 and this can be built using all the values in S, then it's fine that I can just like take all these values, put them in the end this 3-digit number, and then the numbers remaining can be put ahead of those 3 numbers, but it can be in any order, we don't care. The final number will be a multiple of 8, and that's the logic for this problem. I'll take on to the code part now, so I'll show you how. So this is a solve function, this is S, this is a map of integer, because I have 10 digits, so that's of integer vector, because I have 10 digits, so it's from 0 till 9. Okay, then I have iterated over the S and finding out the count of every number. So S of I minus 0 plus plus is just finding out or storing out in the map the count of every integer stored in S, the string which is given to me, or the number in the form of the string, because the number is very large, I cannot store this in any data type, so I have to store this in some string format. If I have stored this in string format, I have to find out the count of every integer in this string format, such that in the end I can easily check that whether this number can be built or like I can build the number which is a multiple of 8 using the digits present in S. So that's what we're gonna do, finding out the frequency of all the digits. So if n means the length of the S, the string which is given to me, which I've told you there are two conditions. If n equal to 1, then the answer is just 8, or else the answer is no. So because I have to, 8 is only the answer. If S of 0, which means that the digit, because n equal to 1, is 8, then the answer is only yes, else the answer is no. Else if n equal to 2, then there are two conditions I have already told you. I can either put a into b, which is the first digit is a, so if you're finding out or converting out this ab, you can also use string to integer like function, or you can also use this, because if you want to convert some string into like number which is just of size 2, so you can multiply the first digit with 10 and the second is just the same, you just add on these values, and if this combined number is a multiple of 8, or if you switch them out, which is S of 1 and S of 0 is just reversed out, you're just actually finding out whether AB or BA is a multiple of 8. That's it. If either of this condition holds, then the answer is yes, because we just have to find out whether we can permute these digits and form a number which is a multiple of 8. So just yes or no. So if this condition, any of these condition hold true, then the answer is yes or no. You just have to return out if any of this condition hit true. If okay, then there's also one condition in which, because as you can see 1000, or if you just have like 3 zeros in the end, this is also multiple of 8. So because if you have 1000 or 5000, because these 3000 this 1000 can be easily divided by 8. So if because you have 3 zeros in the end, so you just have to also check that if the zero values in this, which I have stored out the count, if this is greater than or equal to 3, then the answer is obviously yes. Then I will iterate over from all the values which is of, so I've already told you that I have to find out the 3-digit number which is a multiple of 8. So from 104 till 1000 I've already told you, so I have to increment by a number of 8, and I have to count out the frequency of this I. So this is the multiple of 8. Okay, so I have to find out for this number what is the frequency of every number stored in this. So this is just a 3-digit number. So I'll just find out the frequency of that 3-digit number, the count of every integer in this map2. Okay, using this, and then I have to just find out that whether I can build this number using the numbers I have in S. So how I can check that? I have stored the frequency of this number in map2. So if any number in map2 is greater than the number present in map1, then the answer is like no, I cannot build. Because what I mean by this is that I have some number which is, let's assume 555. This is not a multiple of 8, but let's assume that I have some number 555 and that number has 3 5s, but in S let's assume it only has 1 5. So I cannot build this number using that S string because I have 1 5 in that string. So that's what we're gonna check, that if the count of every number in map2, if it turn out to be greater than in map1, which is the storing out the actual frequency of S, then the answer is obviously no, that I cannot do this. Else if this doesn't hold, which means that every number in map2 is less than, the frequency of every number is less than the frequency present in S, then yes, I can build that number. So thus the answer is just yes, and just return out at this point, because you don't have to check any further. If all of these conditions don't hold true, then the answer is just definitely no, that I cannot make a string of, or I cannot permute it to make a multiple of 8. And that's the logic for this problem. If you still have any doubt to mention down, thank you for watching this video. I'll see you next one. Keep coding. Bye.